Go ahead, Dr. Wu.
Sure. Thanks, Donna. Yeah, just let me briefly share my slides. Yeah. Can you see my slides now? Okay, good. Okay. Good morning, everyone. My name is Hongyu Wu. I'm associate professor in the Electrical and Computer Engineering Department at K-State. I've been with K-State for about years. It's amazing to know that this dialogue has been kept going on for 20 years. That's really amazing. Had it in the past 2 decades. I just want to talk about some research associated with my, empowering the rural electric or rural power grid, especially through the agricultural microgrid. So we have a broader vision of contributing the net zero grid. I'll first begin with the research background, so outlining the challenge of integrating renewable energy in both the bulk power system and the rural energy environments. Next, I will introduce our most recent work on the frequency stability enabled power grid scheduling, so where we leverage machine learning to ensure secure and cost-effective grid operation with high renewable energy. And then I will shift my focus to deep learning technology tailored to enhance rural microgrid energy management. So this also including balancing electricity need with agricultural demand, like irrigation and ammonia production. So finally, I'll wrap up with some conclusion and a reference over there. So as we know, we are facing a global challenge. The climate changes, depleting natural resources, and growing population are putting pressures on our environment. So in figure one, as you can see from the left-hand side, there has been a dramatic increase in global carbon emission over time, which can be direct contributor to the greenhouse effect and the global warming. On the right-hand side, you can see that the figure two illustrates the rising of global temperature. So with the temperature anomaly reaching about 9.9 degrees Celsius above the average in the year of 2022, this is an indicator of the rapid pace of climate changes. Together, those visuals highlight current issue in climate changes, which those trends show clear call to actions. So you're using clean energy with much lower carbon emission is widely viewed as one of the solutions. So now that we have seen the scale of environmental changes, so let's look at the major responses. So in general, the global community is pushing for a 100% renewable energy. So on the left-hand side, the table you can see the United States, Rhode Island and the DC and other states are setting the ambitious clean energy target. On the top right figure, you can see that the projected growth in the distributed solar energy in the ISO New England, which is one of the major ISO in the United States. So in 2010, the region has been less about 80 megawatt, which is almost to nothing of the solar generation capacity. By the end of 2023, the total solar generating capacity come across the six regions, which is about 7,300 megawatt. So installation, which is representing a variety of sizing and location, can produce an estimated of 8,000 gigawatt hour of electricity in 2023. This number I believe to be higher in 2025. So as shown in the bottom right figure, this distributed energy can help us reduce the daytime power grid demand when conditions are right, the sunny days, prefer sunny days, and the solar readiness is good. So ISO New England can see a significant reduction in the regional grid electricity. So basically, you can see the demand from the behind the meter kind of PV, greatly reduced over there. The behind the meter PV drives demand for the grid electricity to a record low when the solar energy reaches its peak. As some of you may know, this phenomena is referred to as duck curve because a line charting representing the great demand on such a day resemble a sitting duck over there. So duck curve, this tends to be occurring during spring in the ISO New England. This is typically when the electricity demand is lowest and also the temperature are mild over there. So as we integrating more renewable energy into the system, especially wind and solar, okay, so the power grid encounter a fundamental issue. So the things are variability and uncertainty. So those resources do not provide constant power, and the uncertainty can be destabilizing the grid. So a little bit background is here is that in the US, the grid frequency is maintained about 60 hertz. So it's a key indicator of the power system healthy. So when the supply and demand are in balance, the frequency stays stable. But when the generation suddenly drops or demand spikes, the frequency can reduce. If that frequency falls too far, it will trigger the protective relay and the tripping the load or shifting the load, or even cause a cascade failure over there. So maintaining frequency is not just a technical details; it's essential to keep our lights on. So let's look at the specific challenges, facing by modern power system, especially in the isolated power grid like Maui Island, Hawaii Maui Island. So Maui has been a significant shift towards renewable energy with a mix of solar, wind, and battery energy storage, as shown in the figure on the left. As we know, traditional power systems rely heavily on the large rotating generators, so which provide inertia. So the ability to resist sudden changes in the frequency. So however, as we integrate more inverter-based resources like solar and wind, we lose that rotational inertia. So this chart on the right illustrates that what happens when a generator trips in Maui. So with high renewable energy penetration, which is shown in the red, so the system frequency drops faster and deeper compared to the lower penetration level, which is green curve over there. So this frequency nadir, which is term used to describe the lowest point after disturbance in frequency, can be cross-critical load shedding and potentially leading to blackouts if not managed properly. So as we scale up our renewable energy, we're also facing the challenges of maintaining frequency stability of a power system. On the other hand, I want to mention that the food, energy, water nexus is also vital for all our lives and is highly interdependent. We specifically look at the electricity and the run ammonia manufacturing plants, which synthesize the fertilizer for food. This process also requires pure hydrogen from water. So as in our group, we investigate an agricultural community microgrid. The community microgrid benefit both the community and the grid, while traditional microgrid are owned by individual customers and typically only benefit that single customers. The cooperation between the rural energy system and ammonia synthesis plant can reduce peak electricity load and allow for chemical energy storage in the form of ammonia. So we believe that the storage in the form of ammonia can provide a long-term storage instead of a short-term, other than other better energy storage system. So that's basically a benefit in terms of the food, energy, and the water nexus over there. Another thing I want to mention is ammonia is very important to the agriculture. So also the bioavailable nitrogen is essential for all lives and essential to the FEW nexus. So manufactured nitrogen-rich ammonia and the derivatives are used to fertilize crops. It has been proven that ammonia used as fertilizer can substantially increase crop yields for the same input of water. Also, ammonia production consumes about 30 to 50% of energy used for crop production. So ammonia is a critical input for global food security. So primarily we use that, over 40% of the world population depends on the food growth using those fertilizer. So that's the things here. On the right, we can see a community-based green ammonia production process powered entirely by renewable energy. So we call that the green ammonia process. They include the water electrolysis to generate hydrogen, air separation to extract nitrogen, and also the Haber-Bosch process to synthesize ammonia. So this allows us to replace fossil fuel and produce ammonia over there. So another thing I want to mention that because the energy consumption is large in this kind of ammonia production over there. So how we can basically optimally scheduling or using our local renewable energy is basically a serious issue in those kind of food, water, and energy as context over there. So let's look at the growing trend shaping the future of power systems. First, we recognize that the rise of innovative energy management system, which can be a pathway to enhancing both electric efficiency and resilience of the power grid. Those systems are becoming smarter and more adaptive, and thanks to the digital technology. So what's driving this transformation is truly a game changer is the widespread adoption of the Internet of Things, which give us unprecedented real-time visibility and control, and also the exponential expansion of data availability, which enable the more intelligent and predictive operation. So by leveraging the AI, data structure, and also analytics, we can now significantly improve how energy is managed, especially in the decentralized and renewable-rich environment. This is also a notable pathway to enhance sustainability, helping us move forward to a more reliable, clean, and resilient energy future. I would briefly talk about some fundamentals, just because time issue. There are basically three types of the machine learning algorithm we basically apply. The first one is supervised learning. The second one is unsupervised learning. The last one is reinforcement learning. So in this presentation, our work focused on the first and third one. So for the prediction and for this decision making in real time system over there. So basically, our work is motivated by answering two research questions. The first we ask is, how can we efficiently incorporate frequency linear constraint in power grid scheduling using a machine learning model for high renewable energy system to ensure the frequency stability? As renewable penetration increases, maintain grid flexibility, or if frequency with safe region becomes a critical operational challenge. The second question we want to explore is how can learning-based control be leveraged to coordinate on-site renewable energy, green ammonia production, and basically irrigation within the food, energy, water nexus? This question is especially important for our rural communities where energy, agriculture, and sustainability goals are deeply interconnected. So together, those questions drive our effort to building intelligent, resilient solutions that benefit both the grid stability and rural prosperity. So finally, I'd like to gratefully acknowledge the support from the National Science Foundation, U.S. Department of Energy, and National Renewable Energy Laboratory for making this research possible. So in the remainder of the talk, I will briefly talk about our research center around answering the two research questions. So the first one is frequency stability enhanced or enabled power system scheduling. So the core research question we'll talk about is how we can basically ensure system frequency stability. So we first explore various machine learning models to predict the frequency nadir under different contingency scenarios. Second, we take that prediction and embedded it as a constraint in a unit commitment framework to better manage system reliability without overly depending on expensive convention generators. Finally, we evaluate our proposed model using the simulation on the real-world cases, which is Maui Island system. So basically, this research objective outlined over there is built on the machine learning to predict the frequency nadir under contingency event. So to begin, we must identify the core system variable that influence the frequency dynamics during disturbance. So we focus on three key inputs. The first one is inertia. Basically, that reflects the amount of rotational kinetic energy stored in the system. The second part, we have the power losses. This is representing the sudden loss of power due to the generator trips or large load shedding event. It is a critical indicator of disturbance magnitude. The last variable we identify out of all variables is primary frequency response headroom. So this is available capacity from online generator to provide immediate corrective action to restore frequency. So that qualifies how much frequency support the system can deploy instantly after a. Those three features are conceptually linked by the swing equation, as you can see from the slides, which govern how the frequency of power system evolves in response to power imbalance. So our goal here is to train a machine learning model that takes those variables as input features and output an accurate prediction of frequency nadir. So we have established input features and rationale behind the prediction nadir. So let's talk about this machine learning implementation. As you can see, the 3D scatter plot on the left shows the relational between the total system and also the inertia, generation headroom, and observe the frequency nadir. So as we expected, we see that the higher inertia and more available headrooms associated with higher the frequency nadir values, indicating more resilience in the power system to sudden disturbance. And also, we evaluate the accuracy of a machine learning method, and we compare 5 algorithms: linear regression, gradient boosting, supply vector regression, artificial neural networks, and XGBoost. So basically, as you can see, figure 10 on the right shows the error distribution of each model. So ideally, we want the prediction error to be centered around basically with the minimum spread, which is clearly achieved by the GB and XGBoost models. Okay, so and also we have using some common quantitative evaluation metrics, MAE, MSE, RMSE, and ME to basically evaluate that. As you can see from the table, the XGB boost achieved the lowest value across all metrics, which is saying that the XGB boost forecasting maybe is the best of across the board over there. The next step, we want to incorporate those kind of a forecast model into our unit commitment models over there. So based on the strong prediction, we can see the UC. So in this section, we treated the frequency nadir as a constraint. So just as an output. So with the past work, basically using the piecewise linear model from the swing equation. So in here, we identify three needs for the integration. The first one is accuracy prediction. The second one is UC compatibility, especially for the mixed integer linear programming. The last one is consistent performance. So based on all those kind of the criteria, we finally choose the linear regression can be selected as this task to integrate the UC model over there. So we actually implement this using the data-driven method, which is frequency-aware, unit commitment model. As illustrated in this figure, the model begins with a high renewable energy penetration system setup, which is basically subject to the frequency instability. So especially after event like generator trips, we use the machine learning and train the historical model and fit into the UC model. And then we use the Unreal developed multi-time scale integrated dynamic scheduling system, MIDAS, to run the whole simulation and look into the resilience events over there. So after design and implementation, the frequency nadir constraints over there, we, unlike the most existing literature, so rely on very short simulation and also mimic the IEEE systems. Here, we basically aim at realistic system level insight over there. So basically, we can see a full year simulation in the Maui Island. Of course, thanks for our collaborator from Unreal and the collaborator from this utility in Maui over there. So we evaluate three cases. The first one is baseline, where we apply the traditional UC model without any inertia or frequency nadir constraint. The second one, we have minimum inertia cases, where we enforce basically a floor on the inertia to protect the frequency, instability. This is also the common industry practice now. The third one is using our model to see how our model can provide the flexibility without compromising the stability over there. So we can compare the three slides, and also this is our validation in the neural systems. This is a flow chart, and the top right figure shows basically the generation mix on the system. So the conclusion we made from this work is that the frequency nadir scenarios which deliver the most balanced outcome, which is our model. So it can achieve the lowest frequency violation count. So basically, it's only 18 hours out of the 8,761. So the total operation cost is $140 million, which is very close to this baseline, which is $1 million more, with only a 0.77% increase over time. So basically, that shows that our model is very highly effective and do a good job in terms of this frequency nadir presentation. The next one, I'll briefly talk about this deep reinforcement learning to enhance rural microgrid energy management. So this is basically our recent work by focusing on the food energy, water system over there. So basically, we look into answering this question. We specifically break this kind of a research question into three objectives. Objective one, which is investigating and the world modeling of energy, water, and crop demand on typical farm. The second one, we develop a deep reinforcement learning based method for the energy management that coordinates renewable energy generation, battery energy storage, loads, and ammonia production. Objective three is basically evaluate system performance through the case study and simulation, determining the feasibility, stability, and also profitability over there. So basically, we want to mention that our basically innovation here is that most of the study in the literature space is conducted regional or national scale. So often basically overlooking the individual farm level dynamics. So our work is basically the farm level microgrid, farm level energy, kind of the synergy between different resources. So basically our goal is individually or exclusively on the farm level. So, and also we have real operational, decisions, especially in sustainable agriculture, made by the farm level. So this is actually coordinating with a large team in terms of agriculture, in terms of water, or in terms of chemical engineering. So our goal is basically need an energy management system at the farm level that integrate renewable energy, like wind and solar, support on-site ammonia synthesis for fertilizer needs, coordinate the water irrigation, and also interact with utility power grid for flexibility and resilience over there. As shown in this diagram, the energy is distributed across the system to power power water pumps, ammonia plants, and crop production over there. So this slide, outline the energy model for farm scale microgrid system. So we have renewable energy. You can see have solar and wind energy. We have energy storage system. We consider 4-hour battery system with balanced supply and demand gap, and also the large charge discharge operation. We also have ammonia generation, grid interaction, and curtailment and balance. So due to the time constraint, I'll briefly go over to this, the next stage. Is that we also use the snow mean to mimic the agricultural growth, crop growth, nitrogen dynamics, and water dynamics. Those are basically have a detailed representation in those software. So this is basically our framework using the deep reinforcement learning. We specifically use the deep co-learning based model to decide decision in terms of electricity, in terms of the irrigation, in terms of the ammonia production. So we basically train the Q network using the Q network, and also the target network is provide stable target value for training. A loss function drives learning through the gradient descent. Those are details through the implementation over there. So simulation, we basically simulate a couple of scenarios. The first scenario needs no irrigation, no fertilizing, which is minimum input. The second one is full irrigation and full fertilizing. This is the most expensive one. The third one is advanced, actor critics, which is A2C. And last one is deep Q network, which is DNQ. So we compare the four scenarios to see, which one is the best according to, our, criteria over there. As you can see from the left, we can compare the crop yield over the growing seasons. You can see the FIFF, which is full irrigation and full fertilizing, in purple, achieve the highest crop yield. The NINF, which is no irrigation and no nitrogen, and AC2 results significant lower yield. Okay, this demonstrates the ability of DNQ to dynamically adapt to the crop needs and weather conditions. On the right, you can see that the input application patterns. The top right chart shows the irrigation level over time, and the bottom right chart shows the nitrogen applications. Again, the DQN solutions is basically the solution which we prefer because it achieves the significant benefit with a little bit increase of the cost over there. So also we simulate this kind of results. You can see from the table that different solutions based on the machine learning model. We can see that DNQ outperform all algorithm in economic returns, and also with significant less irrigation and fertilizing than FIFN. And also A2C is moderate in both input and output. So all those kind of details can be referred to this, the paper. If you have any questions, we're more than happy to answer associated this work. So finally, I want to conclude, basically talk about our work demonstrated the transformative of AI and data-driven method in modern power systems. So first, we show that machine learning can accurately predict frequency nadir, which is a critical indicator of grid stability. This is using the key features such as system inertia, power loss, and the primary frequency response headroom. So building on this, we use the UC model with the MIDAS to simulate in a real-world power system. So the second work we talk about this microgrid side, we explore the typical farm level setup. So talk about this kind of the energy demand, irrigation schedule, ammonia production, the coupling together. So we use deep reinforcement learning algorithm to achieve effective balance among this computing, these different needs. So we can get enhanced operation efficiency. So overall, this work tied directly into the evolution of grid infrastructure by embedding AI into both bulk and distributed energy systems. So it enables real-time adaptability, can improve resilience, and support the transition to a more intelligent, sustainable, and decentralized grid. So to conclude, I just want to acknowledge the source and the foundational work that support this research. This reference list here, including publications on all I talked about before. So if you're interested in, please, happy to share them with you. So after the presentation. So that's pretty much appreciate your time and attention, and happy to hear any questions or feedback. Thank you.
Thank you very much, Dr. Wu. What a rapid and hugely comprehensive coverage of a very complex topic. I am going to select one of the questions to rephrase for you because it might allow you to point to some of your slides. One person asked the specific question, does your modeling tool take into account the use of grid forming inverters? That's a very specific sort of yes, no question, but please elaborate on it. Does your modeling tool
Yes.
take into account? Yes, please.
Yeah, thanks. Thanks to the people asking this question. This is excellent question. Apparently, the question asked is from the is expert in this domain. In our current work, we're not talk about this grid forming, so we didn't think about any grid forming work in here. So we're still using traditional grid following, work right here. But definitely, grid forming is kind of the future of promising areas over there. So we're actively looking forward to explore those kind of work to expand that to see how the grid forming inverter can help with this grid. Yeah, so the quick answer is no, but we're very interested in, yeah.
And another one that just came up, salt-based ammonia fertilizers degrading to the soil food web, which cycles nutrients, builds soil structure, and is the foundation of regenerative agriculture. Thus, salt-based fertilizers adversely affects water infiltration, plant and soil health. Do you have a response to that as it pertains to your research?
That's an excellent question. So, as my part in this kind of a interdisciplinary team is my focus is on electric system. Uh, I don't have much kind of expertise in the ammonia side. So what we do is basically using some existing technology has been in there for like over 20 years, have a Bosch process, and instead of using the fossil fuel, we use the water to get the hydrogen, use the air separation to get the nitrogen, and to do this kind of ammonia over there. So for that question, I don't have answers, but I can definitely help you connect to the work who has been doing in our work. Yeah, here, yeah.
Okay. Uh, I've kept the other questions and we'll be able to use them in the dialogue section. Let's go on now to Dorothy Barnett, Executive Director of the Climate and Energy Project, and she'll be talking about sustainable grid infrastructure. Please go ahead, Dorothy, and we'll give you a moment to share your screen.
And Donna, I'm not going to share any
Oh, that's right.
slides, so
Okay.
I will just jump in. Thank you, Dr. Wu. Always good to hear more, especially about the FEW project. And thank you, Larry, for keeping this going. My name is Dorothy Barnett, and I direct the Climate and Energy Project. I see a lot of familiar faces, so I'll be very brief. CEP's mission is to reduce greenhouse gas emissions equitably. We focus on four areas: clean energy policy, civic participation, and climate resilience. And so the dialogue is something I've participated in for a number of years, and always good to be here and to talk to folks about the work. Um, I want to touch on a few things. I want to touch on the load growth, what we're seeing currently in renewable energy, and then talk about some of the grid enhancing technologies and other work that the Kansas Corporation Commission is focused on as we move into the future. So, for most of the time I have been a part of the Climate and Energy Project, the load growth or the amount of electricity that is being seen um, across the country has really been um, flat or declining. We've not seen a lot of load growth. That's in part due to energy efficiency equipment, and houses being more efficient over time as they're being built, buildings being more efficient. But yeah, the future that we're looking at is quite different in terms of renewable energy growth. We are hearing by 2035 anticipation of 20 to 30% more power generation is going to be needed to meet our energy needs. Um, that comes from a lot of reasons: electric vehicles, home electrification, and a lot of that load growth is expected from data centers. we could have a conversation at some point about the value of data centers. We heard Dr. Wu talk about how effective they are with his work. There are other opinions about that and other things that we should be thinking about, we believe, in terms of data centers. But the future is a growing grid. If you would have asked me 6 months ago where I thought we would be meeting those needs for electricity growth, I would have said, we expect we will see a lot of wind, a lot of solar, a lot of battery energy storage. But over the last few months, we've seen a big switch, and recently with federal policy, the conversation now is more on we'll likely see a lot of clean energy in the next year or so, and then from large energy sources. But really, the future we expect is a lot of distributed generation, and I'll talk more about that in just a moment. Um, we know that here in Kansas, our transmission grid is aging. There is a need to still move some large power sources from clean energy centers, wind farms, perhaps solar arrays. But what we really expect in the coming years, given the lack of federal support for large scale renewable energy, is having more decentralized generation. And I'd like to share a little bit about what we heard recently from Evergy, or from the Kansas Corporation Commission. Someone in the chat had mentioned being concerned about what was happening around the new generation for Evergy. And, I would just say the Climate and Energy Project for the better part of a year really focused on stopping the Evergy from building two new gas plants. And unfortunately, the commission recent order talked about, they approved those gas plants. That was a disappointing order. But I have to say, some of the things that they said in their order was really gave me some hope for where Kansas is headed in how we can really utilize our existing grid in a lot of ways to continue to decarbonize as we need, even amidst the load growth that we're seeing. And so some of the things that the KCC touched on were really the need for Evergy to have a more diverse and less capital intensive energy portfolio. They were very clear that although they approved the two combined cycle gas turbines, that they were looking for Evergy to demonstrate serious consideration of less capital intensive options like demand response, utilization of surplus interconnection sites, as well as what they called grid enhancing technologies. This directive to Evergy from the commission, we believe, signals a significant shift away from an over reliance on large centralized power plants. And so they were very clear when they outlined robust demand response programs, initiatives of demand response, incentivize customers to reduce electricity use during peak times, effectively lowering the overall demand and reducing the need for expensive new generation or the polluting and costly peaker plants that they sometimes rely on. The order was implicit in promoting grid enhancing technologies, or GETs, which is something that CEP that we advocated for during the Evergy rate case. GETs optimize the existing transmission and distribution infrastructure. And so you can use technologies like advanced conductors or dynamic line ratings to increase grid capacity, and make them more efficient without having to build massive new construction. So, so that is something that we think has a lot of possibility. Sometimes that's called grid modernization, which is also something that we're hearing the state house, some of the lawmakers want to focus on grid optimization. The other piece that they really focused on was some comprehensive alternatives. So beyond demand response and the grid enhancing technologies, the KCC mandates that if Evergy wants to build future generation, and currently in their 2031 plans is an additional 1,600 megawatts of gas turbines, then they must evaluate all viable supply side and demand side alternatives thoroughly. This includes directing Evergy to evaluate repurposing their existing generation sites for battery storage, to model battery energy storage in their integrated resource plan or their IRP, as well as to assess investments in distributed resources like community solar and energy efficiency. So while Evergy has finally has some energy efficiency programs for Kansans, the portfolio is limited, and there's a lot more we could do to maintain flexibility, availability, and dispatchability within those resources. The other thing that I think is important to remember, because I have to tell you, we certainly at CEP had a hard day when the HR1 or the BBB bill was approved, because of the recognition that, I think it is the end of an era in some ways for large scale renewable energy generation. It will still continue to be built. We might see a really large, fast build out in the next 18 months, but industry overall expects a fairly big drop off of particularly wind and solar. Other low carbon technologies will have a longer runway of support. Things like hydropower, hydrogen production, battery energy storage, geothermal technologies, advanced nuclear, all of those technologies will still continue to have support from favorable support from the tax code and from the federal policies. But wind and solar really took the brunt of that. But I was listening to a podcast that I'm going to drop into the chat this week that really helped me think about Kansas in particular. More than 50% of our generation in Kansas is carbon-free electricity, and nobody's taking that away from us. We have worked long and hard for that over the past 20 years. And so despite the fact that it may feel like we've moved 3 steps forward and 2 steps back, we're still 1 step forward. And I believe that we still will continue with the smart work of people like Dr. Wu, and the work of my colleagues, be able to really think through how we continue to decarbonize and the role that the grid will play. And with that, I think I'm at time, but looking forward to the dialogue. Thank you.
Thank you, Dorothy. I have a comment and question that was contributed here regarding rural electric cooperatives. Rural collective electric cooperatives have been resistant to distributed energy production. And the writer says that our local co-op implemented a $1,000 application fee and very strict export limits. In the 1990s, households had both grid connected and independent circuits. This is households. Is there a way this microgrid can be designed to operate in parallel with the rural electric distribution systems? Do you have anything to say about this at the household level?
Well, I would say hello, Bill Dorset, and you could probably answer this question much better than I. But I will say that there are a couple of positives about what's happening, at least at the State House right now, at the Kansas State House. As you know, Bill, through the Clean Energy Business Council, we were able to get some net metering concessions a couple of years ago from Evergy. And in this most recent legislative session, we were able to get some parallel generation concessions that are supposed to bring the co-ops and the municipal electricity, the munis and the co-ops, supposed to be bringing them to a more level playing field with the investor-owned utilities in terms of what they can and can't do around net metering. So, Bill, I appreciate a chat offline about what you're seeing and what additional things need to be changed in order to get those co-ops more on board. I think that, especially rural cooperatives and municipal utilities they see renewable energy as competition. They see it as something that's taking away their their opportunities to generate power and to be in control of power. And so hopefully, Bill, during the dialogue portion of this conversation, you can bring in some thoughts and some insights because we're not going to have the opportunities for large scale renewables in the near term. And so we really need to be able to focus on getting munis and co-ops on board with, maybe it's grid modernization. Maybe that's where they will begin to support renewables more, because the municipals and the co-ops have in recent years especially been concerned about the cost of transmission. And so if there were a way to weigh in with them and talk to them about how grid modernization could not only help with distributed generation, but could help lower costs as well, that may be something that we could focus on.
Thank you, Dorothy. This is a good bridge to the focus on Kansas since you have been talking about Kansas Corporation Commission priorities for Zach Pistora's presentation on sustainable grid infrastructure in Kansas. He's the director of the Kansas chapter of the Sierra Club. And by the way, everybody, thank you, Dorothy, for adding that link. Keep your eyes on the chat, everyone, because people are putting good resources, including upcoming meetings, into the chat box. Go ahead, Zach.
Well, thank you, Donna. Thank you, everyone, for being here. Honored to be before you, and amazing. This is the 20th annual Dialogue on Sustainability. I hope we get 20 more years and beyond, because this topic is so important as far as sustainability broadly, and then sustainable electric grid specifically. I do want to kind of outline the landscape of electricity and our grid here in Kansas, but it just occurs to me, if we want to have a sustainable grid, I first want to talk about making sure that we reduce the unsustainable fossil fuel usage portion of the grid for our power. So that's the first part I want to go into before I talk about how we can incorporate some of these more sustainable technologies into our mix and what drivers those could be. Now, to paint the picture first, reducing the fossil fuel use for power is really important because in Kansas, we're looking at 27% of our power being sourced from coal. And that's significant still, but it's down from 61% from a decade earlier, based on information from the Energy Information Administration. Today, that's still 651,000 tons of Wyoming coal we're burning. As you probably know, that's toxic air pollution and atmospheric pollution still escaping from that choice fuel. We're talking about sulfur dioxide, nitrous oxide, depositing mercury into our landscapes from that air pollution, which all leads to respiratory illness, asthma, shortened lifespan, etc. Not to mention perpetuating climate change by burning the fossil fuels through greenhouse gases. And for our largest public utility, that is Evergy in Kansas, my previous analysis showed that our coal plants emit 12,000 hot air balloons a day for a visual representation. So just think about those hot air balloons being filled with greenhouse gases, escaping to our atmosphere one by one, every single day, all days of the year. From national standpoint, we're talking about 80% of our coal burned in the United States goes towards electricity. So we got to get coal use down to be able to move to a sustainable grid. We have 9 coal units here in Kansas. These are coal units that came online in the 60s, and many of them built in the 70s. And so we're talking about still relying on 20th century technology, 50 some years of power generation, when we could be moving toward more innovative, beneficial solutions to clean up the grid. Let's talk about gas. Currently, we're at 8% fossil gas being used, but that's anticipated to grow. Currently, that amounts to 2 billion cubic feet of gas being burned on an annual basis. Of course, we're expecting 2 new gas plants from Evergy. That's recent news. They'll be built in 2029 and 2031. Of course, when we talk about gas, we're talking about a very explosive fuel source that has exploded before and killed people. I can say in Hutchinson, Kansas in the past, it leaks methane, which is a very potent greenhouse gas, 86% more potent in a 20-year period compared to carbon dioxide. And a number of other reasons, relying on fracking, for example, that intentionally contaminates water supplies, and the method of bringing that fossil fuel up to the surface, only to have to be injected from the wastewater back into the deep underground, which we know can cause man-made earthquakes in Kansas. So there's a lot of externalities from using these fossil fuels. Nationally, 40% of the electricity is sourced from gas and makes up 42% of our grid. Regionally, and I wanted to put a important link into the chat here. There's a way you can keep an eye on how much we're using energy in our daily use. That's the Southwest Power Pool, which Kansas belongs to, is our regional power pool. And, earlier this morning we were using, if you click on the pie chart, 54% wind. I think it's down to 44% last time I checked. 22% coal earlier in the day, I think, or 22% closer to coal now. 21% gas. It was 1% solar when I started the morning. It's up to like 1.6% last I saw. So regionally, we're increasingly use more wind power, which is good, but we have an equivalent, if not more, of our power still being sourced from fossil fuels. On average, we're about 34% wind, whereas we're about 35% gas and 22% coal as of last year in using fossil fuels. So we really got to reduce our dependence on fossil fuels if we want to make a transition to a sustainable grid. Looking ahead, a couple more resources for you. Our largest utility, Evergy, in their 20-year forecast of energy, actually calls for more fossil fuels to be built than renewable energy. And that's unfortunate because only 4 years ago, their 20-year forecast had no planned fossil generation. Now we have so much of it depending on fossils, mainly gas for our future, which is too bad. We're talking about 4.4 gigawatts of gas. We're talking about coal retirements being delayed. 2 gigawatts by 2033, but that was after Evergy promised 70% emissions reductions by 2030, and it's probably not going to be able to meet that target with their new plan. We still have 3 gigawatts of renewables on the horizon from Evergy, but that's down from 3.5 not too long ago. One important thing to think about is where are we using our energy, and and how can we get the end use sector of electricity down so we can reduce that fossil fuel usage. If 89% of our coal is being burned for electricity, then how do we reduce those in sector uses? And there's a couple of options. One, there's a radical cultural and lifestyle change. You know, I'm thinking about 40% of our electricity goes to residential use, what we use in our homes. So can we radically change that? Can we reduce our energy use in our households 10%? You know, and could that prevent the next gas plant from coming online? Sure, it could. We've already adopted lifestyle changes across America, like passing on plastic. We could get outside more and spend less time on screens. Of course, it's beneficial to be on Zoom to reduce our transportation fossil fuel use dependence. But could we do more to reorient our lifestyle and society to depend less on electrical needs? Could we have radical energy efficiency? Which we could do a lot more in Kansas, because for our state, we're considered second to last in terms of helping our people save energy at their homes and businesses. So we could do better in conserving energy. System-wide, we could do a lot better too. If you look at the Energy Explained from Energy and Information Administration, you'll see that 59% of all the energy in the electric sector is actually lost along the electric grid. 41% is actually used. So how can we upgrade our transmission systems to carry more power without new generation, maximize the efficiency of our system to utilize more of that power? Flip it around. So we use 60% of our actual energy and only lose 40% or even less. Let's go more distributed energy, more localized energy systems to harden the grid, but also have our power generation be a little bit closer to the places we use them. Unfortunately, using less is probably a less probable scenario with the oncoming of data centers, and I'll get to that here shortly. Our better solution is likely a replace and substitute of fossil fuel with more clean energy solutions. Good example is, you heard it, Kansas is 46% of its power, almost 50%, and often more on certain days, is wind power. And just to think that all has happened in a span of 25 years, actually closer to 20 years, where wind has become our primary majority electrical source. That's amazing. And we could do more with solar. Currently, for being one of the sunniest states in the country, top 10, we're second to last in terms of solar power generation. So think about it as if we had all this fertile soil and we weren't farming, we were second to last in agriculture. That would be nuts. It would be inconceivable. So we need to do more to take advantage of our solar resource that doesn't emit pollution, doesn't use water, and matches that summer peak demand where we use the most power, calling on air conditioning, especially helpful for increasing climate change and extreme weather. We could also, and that can come in the form of utility scale solar farms, which with the approval of the gas plants, we also got approval of Kansas's newest and largest solar farm outside of Lawrence. That'll be 159 megawatts. That's the first big one, and we'll have more coming forward. But we could also use more distributed rooftop solar on our homes and businesses and parking lots, etc. And that actually is more of our solar power today, and could be an important source going forward. Dorothy talked about some of the grid upgrades already, and as well as Dr. Wu. I don't want to go into too much of that, but Kansas is home to what will be the largest transmission line carrying 5 gigawatts of power in terms of the Grain Belt Express. We could also utilize add storage to the system, both in terms of short duration battery storage like lithium ion, which is 90% efficient, but also long duration battery storage like iron air battery systems, less efficient, but a longer span. And then we can sequence those batteries together to create a longer duration effect, as well as other long duration storage systems like compressed air energy storage, which Kansas would be uniquely suited to because that compressed air needs underground formations, large formations to store that air, then to bring it back up and spin turbines. Kansas geological formations and depleted oil and gas wells could be a good option for that. And as well as hydrogen. Our renewables in Kansas and the opportunity for us is really vast. And so utilizing renewables to create hydrogen, green hydrogen is called, is a huge prospect, and we'll see the cost curve come down. But also Kansas is one of the few states you could say blessed with the opportunity for geologic hydrogen, and that does come with its own concerns. But natural hydrogen, white hydrogen as it's called, is relatively pure. 90% and above pure hydrogen coming out of the ground, which when burned creates water vapor that's better than other toxic pollutions from other fossil fuels. If I may, just a few minutes on how we can get there. First, we need better accounting and cost-benefit analysis. Right now, our utility planning and regulatory planning does not include the hidden costs, the social costs of burning fossil fuels, as we should include. KU Institute of Policy and Social Research estimates that there's a $51 added cost megawatt hour for coal, $21 per megawatt hour for burning gas compared to $0 for renewables. We need to think about water, and water is such a huge concern for Kansas right now. So that could be a constraint and a limiting factor for our energy going forward. So let's prioritize energy forms that use less water, like renewables. And then, of course, when we think about power outages, ironically, and not surprisingly, climate change and extreme weather are the predominant reason for our power outages in Kansas. Evergy estimates more than 70% of their power outages are weather related. We see fossil gas fail and during winter storms like Winter Storm Uri more than any other resource. We see outages to maintenance of fossil fuels and equipment failures. Jeffrey Energy Center, not too far away from Manhattan, Kansas, one of their coal units was down for a whole year because of a fire. So that's lost capacity on the grid. More incorporation of clean energy solutions could help create a more sustainable grid and more resilient functional grid going forward. And a big game changer to help make that happen, besides the moral obligation, besides better accounting and cost benefit analysis, are going to be our biggest and newest energy users in Kansas going forward, which is going to be a game changer for our energy load. And those are data centers. But they can also be the drivers of the sustainable grid we need. These data centers use 100 megawatt, 200 megawatts of power. We've already seen 192 megawatt data center proposed, as well as a 600 megawatt data center proposed in Wyandotte County near Kansas City, Kansas. And for comparison, Evergy's newest gas plant is 710 megawatts. Okay, so just a plant or two of these data centers can create use as much power as one new gas plant, billion-dollar gas plant. So we forecast a need of more power, up to 8 to 9 to 10%, even more of electricity by 2030 based on these data centers. Evergy estimates a doubling of the grid generation need in the next 10 to 15 years. So that's largely driving the demand for electricity in Kansas. But those same companies, wealthy companies in America, Apple, Meta, Facebook, Amazon, that are building these data centers are also some of our most wealthy companies. They have sustainability commitments. They want to be able to bring on clean energy to match their demand, but they need regulatory flexibility to do that. And so we want to provide them a 24/7 clean energy capacity, more opportunity to utilize renewable energy credits, green tariffs. They need to be able to co-locate a solar farm and a battery storage facility right next to the data center that offers benefits to the data center as a backup power use, but also can benefit the grid more holistically. So I know that was a lot. We'll get into more of it in the question and answer, but I just wanted to say that, to get a sustainable grid, we need to reduce fossil fuels. We need to use less of them. We need to replace them sooner than later. And there's a couple ways we can do that by better accounting, better willpower, people power to match the electric power, and then also data centers to help drive that. So thank you very much.
Very good. I want to bring everybody's attention to one of the questions while Zach was wrapping this up about the companies. And this will feed our dialogue a lot, I think. Do we think these companies are still going to be clean energy friendly in the current federal administration? And I think there are political and social and cultural overtones to everything that we've been talking about. But Zach, how do you see us, before we move on to our last speaker, working with regard to companies and federal administrative controls?
Yeah, so certainly the policy landscape, especially at the federal level, has changed, and it is adding costs as far as renewable supplies of energy. Fortunately, those biggest companies I just named still have their sustainability commitments. Now, that's matched with the also pressing concern that they can get these data centers and artificial intelligence technologies built, installed, and running faster than other companies worldwide. We're in a global race to be a leader in AI. Those sustainability commitments are still being carried forward. We're hearing from companies like Google that want to maintain it, that have ethical responsibilities, both with their artificial intelligence and how it's used, but also that is powered by clean energy. And even if it comes at a little more of a cost, we're still seeing those commitments being honored. We need to do more to help match that with the technological output and regulatory reform to make those commitments come to actualization. But right now, we do think that they will keep those commitments.
Good to hear. Okay, we have an opportunity that was not announced in the original schedule, and that is to hear from Nate Blair, who is the Group Manager of Distributed Systems and Storage in NREL, National Renewable Energy Lab. So here is a member of our federal workforce, and he has promised to give us about 10 minutes of updates on his side from National Renewable Energy Lab. Thank you for coming in, Nate, and thank you for preparing for a short introduction to your work here.
Thank you so much, Donna. Can you guys hear me?
Yes.
Okay. Hi, I'm Nate Blair. I'm a group manager at NREL, as she mentioned, and I'm also related to Larry, which is the connection that got me involved here. At Larry's suggestion, I've got just a couple of slides that I'll try to share here. I'm working off I have a broken computer, and I think we all know what that's like. So I'm working off a loaner laptop, so hopefully this works. But I just wanted to quickly jump through a few key or a few potentially helpful apps and data that we have. I've spent a bunch of my time at NREL helping build apps and data for the grid, etc. So am I sharing my slides, Donna?
Yes.
Yep.
Yes.
Okay, so we'll go here, and so we have a wide range of things coming out of NREL that other people can take use of and pick up. And I think that's kind of the focus of what I'm talking about. Some of that's just data. Some of that's data like these maps. I particularly love this map in the upper left corner. We built this some years ago when Germany was the leader in solar deployment. And people are saying, well, it must be really sunny in Germany. And I was like, and we were like, it's, if you look at this map, it's quite clear that Germany is about as sunny as Seattle. And so it was really policy and incentives in Germany that really drove that adoption. I don't have a picture of Maui, but I do have a picture of Kauai. So hearkening back to the earlier presentation that talked about Maui. So we have a lot of capabilities there. Another recently added tool that I think might be useful in Kansas in particular is our Inspire tool. So we are doing a lot of work in agrivoltaics. And I think it kind of fits a little bit with the microgrid control talk earlier. And this is a growing field, and this Inspire website, I've got the link at the bottom there, does a lot of work to provide resources to the agricultural sector, not just about agrivoltaics, but also about like how much money could I make as a farmer potentially, and really trying to enable kind of some of this both utility scale and agrivoltaics in the agricultural sector. So it's a pretty broad tool. The next tool, which I've worked on quite a bit, is our annual technology baseline, which is perhaps a little misleading as a name and not very catchy, but it provides current and future costs. So it's very brave in the sense that it goes all the way out to 2050. And the goal of this website is to gather and provide as an Excel workbook everything we know about current costs of renewables, but also conventional technologies. We then use this as a data source for a large number of other analysis projects. So this helps us stay consistent across NREL. And this has a lot of information on each of the technologies, as well as then you can just download the cost data. And this was one that Larry had found as well. This is the slope tool. It allows you to, for example, type in a zip code and come up with a snapshot for your county or your state across a lot of data sets that this team has curated together for you. The goal is to really enable local planning. So it has information in a couple different areas. So sort of similar to what Zach was just talking about for Kansas, it will give you what's that breakdown of generation data for your state or your county, what's the EV penetration, and then sometimes what's the kind of the forecast going forward, what's a likely amount of solar that could be built in your state or your region according to our analyses under a bunch of assumptions. So it can be pretty complicated, but it also can, there's ways to get in quickly and at a pretty high level as well. So, and any of these, you're welcome, you just type NREL and then the name of the tool and it usually pops right up. NREL has a long history of doing work on fuels, biofuels, E85, E15. I was recently in Kansas and I was and Nebraska and Iowa this summer, and I was always baffled by all of the different fuel options at the pump. We don't have all those in Colorado, but the point being that this website has done that. It also now has moved into EV charging, and so it has an app for finding EV chargers if that is difficult for you. Also, kind of on the local or regional planning side, NREL has a suite of tools around optimizing EV chargers. So trying to help the deployment of EVs is an interesting one because it's a combination of OEMs, consumers, infrastructure stakeholders, and government, right? Because it's a very much a chicken and an egg on the charging side, right? People don't want an EV until there's a charger. You don't want to build chargers till you start having EVs, or you can't make money on chargers. So there needs to be some motivation, and this is part of the federal government's effort to try and help facilitate that and optimize that. So this can really help try to figure out how many chargers you're going to need based on anticipated growth. This is another tool, PV Watts, which is really easy to use. It has 5 inputs. You put in your address, how much PV you're thinking about for your roof, the orientation of your roof, and then it spits out, this is the amount of power you're going to get. So depending on what you pay for that power, you can calculate then roughly how much money you're going to save every year with that. We use this. The website's great. We also have most of the distributed solar companies using our website in the background of their other tools. So if someone comes to your door, they might be using PV Watts to help give you that estimate. So they like that it's a third-party independent app. It was interesting what Zach was saying about the future of the energy mix. NREL and other organizations take a crack at this every year. So we are in our 7th year of standard scenarios. We started in 2015, or I guess, we're closing in on our 10th year of standard scenarios. I didn't realize that. And we put out a report, and for the first several years we just put out a report, but now they've built a website around this too. So you can, examine for a bunch of the different scenarios. There's now more than 19 in the last couple of years. Kind of the mid case, or what is kind of anticipated to be likely to happen, and then lots of side cases. What if we get to 100% renewables? What if we have cheaper renewables, or cheaper gas, or more expensive renewables, or cheaper fossil fuel, or cheaper carbon capture technologies? We have some breakthroughs. Lots of different scenarios are run, and you can examine the results by state or by technology in this app. And so that's a fun place to go if you're thinking about the future for particular sectors or technologies. All right, I went pretty quick. Hopefully I got in under the wire, Donna. Happy to answer questions.
Okay, thank you very much. I would like to open up the floor for people to raise questions that these collective presentations have given you. And I'm going to actually go back to a couple of them that I think need to be addressed. One of them from Bill Rausch had to do with a Texas model. Bill, would you like to take the mic and restate your question? Bill Rausch.
Was that about the one plant that Texas just opened?
Yes.
I was just highlighting that Texas and ERCOT, which is the SPP of Texas, of most of Texas anyway, has built a tremendous amount of solar very recently. In the summer, you might have noticed that there haven't really been grid problems in the sense of not enough power for the summer loads. And so I was just pointing out that Kansas, that one plant is probably as much as all of the solar utility installed solar that Kansas has. And Texas probably has 40, 50 more of the equivalent of 40 or 50 more of that size plant. So it just shows the potential for solar in Kansas and the benefits that we could reap just like Texas was the point of that.
Mm-hmm. You also had a comment that you put in that I think would be a good launch for discussion here, in which you summarized tools for the stronger grid. And you talked about reconductoring, better transmission cables, dynamic line ratings, advanced power flow control, and demand response. In that summary, I have a question for everybody as to whether they feel that these are actually now being implementable, are just facing more adaptive constraints in terms of policy decisions or control by certain players in the system. In other words, are these solutions now implemented but not actually at the scale that we need to have them?
Donna, I want to talk about that just a little bit. I think I mentioned that grid optimization is kind of a hot button topic. We're seeing policies being implemented across the states to require the utilities to look to grid optimization, or being able to utilize the grid more effectively as a way to stave off some of the large scale cost, whether it's a fossil fuel generation or a renewable generation for that matter. And I am hopeful, since the commission gave that strongly worded order to Evergy that they needed to really seriously consider these things. But they didn't say you have to. There's no law that says they're required to do anything other than submit the IRP annually. Our integrated resource plan or our IRP doesn't have the same kind of mechanisms that other IRPs across the country have, where the commission can say, no, try again on an IRP. And I think part of that is because Kansas has only had an IRP since the merger of Westar and KCP&L. Prior to that, we weren't required. There was no requirement to even file an IRP. And so I don't think it's a matter of, I think the technology is there. I think we've seen that. I think there is beginning to be more technology focused on grid optimization. But I think it's possible we may need regulators, or the Kansas Corporation Commission may have to intervene and say, no, really, you have to do this. We're done giving you a free ride at the ratepayer's expense. Kind of my 2 cents.
I do want to tell people that Nate's going to make his slides available. All of these slides that have been presented will be on the website. And so all of the links that you saw him present from NREL will be available. If you want to put a few of those links in the chat, Nate, while we're talking, that would also be helpful. So we've got a lot of comments and a lot of links going on in the chat, and I'd like Nate to summarize what he just shared with Bill on the economics and density on agrivoltaics plants.
Sure, happy to. Bill asked if we are looking a lot at dual axis tracked systems for agrivoltaics, and I wrote back that first of all, I'm not an agrivoltaics expert at NREL, but I have been following it some, and the systems that we have been looking at in general follow along with what's the convention in utility scale solar generally, which is single axis tracking. So there's rows of PV panels pointed north and south, and they tilt from east to west. And years ago, they were all flat pointed south and at a tilt, and they didn't move. And we've moved to that tracking system because the cost of trackers have come down dramatically. So it's all in economics, and so the additional output pays for the tracker and then some. Trackers also allow you to potentially shed some of the soiling and snow in northern climates more easily, and there's some people think it helps protect from hail if you have that kind of really detailed controls. But to Bill's question, I think few, if anybody, people are looking at dual axis tracking. The cost of the foundation, the monopole, and the really more accurate tracking is typically much more than a single axis tracker. And with the single axis trackers, in general, they're talking about raising them up higher for agrivoltaics so that you can grow larger crops and or get more equipment underneath. So anyway, that's what I know about it, at least.
Well, we've been hearing speakers address this issue of grid sustainability. Would anyone care to respond to the speakers with a statement or a question about key takeaway ideas that you're going to be thinking about from this? Is there something that stood out for you that was either absolute news, or you think this is something you need to take and work on yourselves? We've mentioned a few. Yeah. Yeah, I know some of you, like myself, have been a little overwhelmed with the new information that's technical and above my pay grade. But I'm particularly responsive to Dorothy's discussions of, how we influence decisions as consumers and as members of a voting public, as members of this actual grid area. I kind of wonder how people are responding to the opportunities to take the technology into commercialization. I'm terribly excited by the first presentation, but I'm wondering what are the next steps before that starts getting introduced and funded for implementation? How far are we from that adoption?
And Donna, I was especially, all the presentations were awesome. Thank you all for presenting and giving us so much great information. I was especially heartened by Dorothy's take on how the Kansas Corporation Commission is trying to keep Evergy accountable. But I do think so my next steps feel like I need to keep pressure on the KCC and Evergy as well as a consumer saying, hey, we still want solar, we still want wind, we need you to quit, get out of the fossil fuel. I'm disheartened that we're building 2 new gas plants, but it got approved, so now we got to deal with it. I also was interested in the data centers. I didn't realize, I'm just a consumer. I didn't realize that they were planning on building a couple, or that were, because I'm sure we're going to give them huge tax breaks and all that kind of stuff. If they could, build the solar plant to fund, to generate the electricity that they're going to need, then it's a net positive for Kansas. But if not, it's not. So we also need to keep up the pressure, I think, on individual companies, because I'm really worried with the current administration that a lot of people are going to let all their energy commitments lag because it's no longer politically advantageous to them, right? So as a stockholder and as a consumer in America, we need to keep up our pressure on companies as well. So those are my takeaways right now.
Those are really, really good takeaways, Susie. And one of the things that I would say, over the last few years, Kansans have really come through with their public comments to the commissioners. Um, I think one of the reasons we have some energy efficiency in Kansas is because during the energy efficiency rate case a few years ago, over 1,000 Kansans submitted public comments, which is huge for such a kind of obscure process as the Kansas Corporation Commission, which most people have never heard of. Um, so much so that the chairman reflected that in his order. He said we've never had so much public engagement before, and so I think continuing the pressure, despite the fact that the commission again approved those gas plants. They approved, I want to say predetermination was what that was called. So what they essentially said was, yeah, go on ahead and start. But they did put in some safeguards that if costs are coming to be 115% of what was approved, they're required to go back to the commission and either ask to stop, or they have to give the commission a darn good reason why they should be allowed to proceed. Additionally, one of our biggest problems with the fossil gas plants, aside from pollution and water use and greenhouse gas impacts, are the financial risk of gas prices. Gas prices have been relatively low for a number of years, but one of the reasons wind energy really began to take off in Kansas in the early years was because of utilities being so over reliant on fossil fuels, on gas. And when we saw gas prices dip into the 13, 14, 16, $18 an MMBTU, people couldn't afford to pay their bills. And while I'm not suggesting that's the numbers that we will see, there isn't anything that indicates gas is going to stay cheap like it is. And so the commission put in some safeguards around the fuel prices to say, you have to have a plan for getting gas to the plants. You have to have a plan for how you're going to hedge gas prices, because unlike coal, where you can, buy a pile and have it sit somewhere, gas is purchased as you need it, and it's all about supply and demand. And that cost is just passed directly on to consumers as a fuel cost. So there were some things about that I, think are good. Um, still disgusted that it that it got passed, but I think the people that weighed in really had the commissioners listening to you. So
We have one of our participants that was very interested in energy storage systems. Guatemala, would you like to talk about this? I would love to see states investing in their own renewable energy production, state control, and how can we support that process? Do you want to elaborate on that idea of just states investing in their energy production and what implications that has for the larger grid and the regional subdivisions of control? Would you like to elaborate on that a little bit?
Hey, good morning, Donna. Thank you for
I'm sorry.
sharing, and all the speakers as well. Really appreciate all the information and knowledge. Oh, yeah. I mean, I don't know. I see it as almost like a kind of security thing for states to have their own kind of self-regulated power production, especially because they're kind of in control of you know, most of their land. That could be like a really cool kind of integrated mechanism to just kind of support yeah, I guess like power security. And really the biggest thing that I've seen in the renewable industry is the storage of the power. That's the big issue. The sun is shining all the time, and especially Midwest and the brighter places, but it's the storage that's always the thing. So I've heard some cool kind of technologies coming out, but they're very small and kind of starting. But I think when uh, energy and power storage really like becomes very efficient, that then efficiency of renewables are a little through the roof or whatever. Because always the complaints like, oh, you power it when the wind's down or when the sun's not out, or but yeah, so the storage issue is the big thing. But anyways, yeah, I'd just love to see like a power, like state-run power cooperative that is paid for, by its people, and they put their funding towards it. And because that's another thing that we've seen is that a state can kind of allocate its own funding. So even if federal funding is not available, that's something we've seen in some of the tribal communities that the state can choose to make that an option. And yeah, just I guess finding the right people, connecting them with the right, entrepreneurs or, businesses. And that I would just love to see that. So hopefully one day, but that's pretty much that. Thank you.
Thank you for that. Now, we had a contribution from Bill that might pertain to this in terms of putting power into the hands of consumers. Can you describe the PACE tool that enables energy efficiency and solar awareness of consumption? Elaborate on that, Bill. What Kansans would have if they had access to this tool that might empower them to move towards more state-centered or regionally centered control.
Well, PACE is, I believe it's property assisted clean energy or something like that. But the important thing is that it's a financing tool that is county based usually, or some kind of district based. And it allows to stretch the term of the loan out long enough to where the payback is immediate. In other words, your monthly payment to do something that lowers your energy bill is less.
As a consumer.
Yes, as a consumer is less
Okay.
than the amount that you paid for the equipment or the tools or techniques that lowered the bill. And that is such a hurdle for so many people because you always hear questions about payback. What's the payback? Well, many people don't have time to wait 2 years, 3 years, 5 years, 10 years, for something to pay back. They need some response immediately. And that's what PACE enables. Missouri is a very interesting program. It's not statewide. it's kind of by districts and counties and things. Other states do it statewide, which is honestly preferable, but each state has to do it the way they want to. But it enables a bunch of energy conserving and solar activity that is affordable for ordinary consumers.
Bill, I might give you just a little bit of so PACE generally in Missouri is commercial PACE. They don't have access to residential PACE. And so in part because there was a big kind of blow up around residential PACE, mainly in California, where consumers were taken advantage of, promised big savings that didn't appear with some unscrupulous finance folks. What we have, if you're an Evergy customer though, what you do have access to for your residential needs is on-bill financing, which is essentially, program was originally called Pay As You Save, where you can have an energy audit. Evergy comes out and does a review of your home, does an energy audit, and then they come back and say, if you had this much upgrades to your home done, whether it's your HVAC system or it's your insulation or caulking or any number of things, you could save 80 to 90%. You could save save enough money that you would be able to be paying for those upgrades over a number of years on your energy bill and still come out ahead, kind of as Bill said. And so I think for residential customers, if you're a Midwest Energy customer, they are a co-op. They have something similar, an on-bill financing program. Evergy now has an on-bill financing program. But in Kansas, commercial PACE is what was being promoted at the legislature that we never were able to get passed, at least not at this point. So just a couple things on that. And then could I just for a minute go back to the earlier comment around state power needs, and whether or not we could focus on that. Nebraska is the only state that is a public power state, meaning power decisions and the energy generation is made at the state level. And so there has been a pretty substantial push over the last few years for what is being called energy democracy or power democracy, where we're looking at energy as a human right, and we're looking at it as people being involved in kind of all aspects, and then being able to choose as a part of that you're not giving profits to monopoly utilities. I think of it a little bit like one giant co-op, one giant cooperative where we're all members and we're all supporting the grid and supporting the generation, but we're all reaping the benefits as well. And so I think there's a big push for that, and a great resource is the Institute for Local Resilience. ISLR.org has a lot of really great information about that. The other piece of that is Kansas doesn't have an energy plan. That could be an interim step to some sort of energy democracy if we moved to that. So sorry for hogging the mic, but I wanted to weigh in there.
I've got a question from Jerry Snyder for anybody that can answer it. The Grain Belt Express is currently under threat of not being built. How important is this project for Kansas and green energy? Jerry, do you want to give us a little background on that and the context of that question? And then anybody chime in on
Zach might be able to answer that.
Yeah, so the Grain Belt Express project proposed by Invenergy was proposed as a 5 gigawatt, so 5,000 megawatts, up to 5,000 megawatts of power that would take it from Kansas, kind of central western Kansas, to all the way to Illinois. And that got approval at the various states, so Kansas, Missouri, Illinois, etc. And takes a lot of the wind power that is congested or that could be developed in western Kansas. This is some of the lowest cost energy of all energy sources in the country. That cheap wind power, some of it not being used. That's per not enough transmission lines or outlet for that energy. Take it across to some places that could use the power. And recently, we just heard that Senator Josh Hawley, for example, and Missouri Attorney General are saying, hey, we shouldn't build this project. This is going to promote energy form that we don't agree with, etc. But that is such a huge transmission line that not only will it open up the renewable resources along its route, it can power some of these data centers, these large energy users that were going to be requiring energy. And so it would be actually not only supply existing demand with clean energy, but it can also give the opportunity for new data centers and those new energy demand to be sourced with clean power. So it's facing a little bit of a political hurdle. You know, I just remind people, especially if on the conservative side, like Senator Josh Hawley, Republican from Missouri, say, remember, the president declared an energy emergency. And if we take that at face value, then we're going to want all the energy domestic forms. And if we actually true up the accounting of what these energy forms, the costs and benefits of them are, we'll actually see a better position for renewables going forward. So I hope that answered your question. Just while I'm thinking about it, you know, I'm thinking about sustainable grid, but in terms of electricity and the technological power solutions, but it really, and that's why this dialogue is so important. It's not the technology really isn't the problem right now. In my view, it is the people in the political landscape. It's the willpower. It's the people power. And so we need a sustainable grid of people and resources, human resources. And so dialogue that brings together academics, engineers and scientists, government, private sector, advocates, consumers, tribal communities, and marginalized communities that can get an opportunity to be our energy innovative energy forum community hosts to benefit them socially and benefit all of us socially, preserve our water supplies and ecosystems. That's the sustainable grid we also need. And so the exchange of information is really important, accurate information, and that social willpower is really important. And it dawns on me the same time we're having political forces that say, no, these clean energy forms aren't good for whatever reason, and insert excuse, is the same political forces trying to defund our universities for talking about either social inclusion programs or climate change, etc. And so I'll just put that out there, is that the fabric of the opportunity for solutions in all this really comes back to people and how we ask for those solutions, demand those solutions, and work for those solutions. Thank you.
Speaking of emergencies, Jennifer mentions that there were the massive power outages that occurred in Spain and Portugal, reportedly were due to lack of rotational inertia generation. And she asks, how do we overcome that problem? Load following peaker plants? Anybody want to address the emergency situation and in its response when regional parts of the grid are down and how quickly we respond? That's a technical and adaptive challenge, is it
I think
not?
It's
yeah, I
one of
think maybe I can take a first step, and the other speaker can step in. And that's a great question, actually. So I think especially for this sort of inertia, basically from this kind of a traditional inverter, the frequency stability and blackout can be apparent, especially recently in the Iberia over there. So I think technically solution has maybe several fold. The first one, as one of the the audience has mentioned, that the grid forming inverter, basically that can be a major solution to that. The grid forming inverter basically regulates the voltage and the frequency, which contribute to the universal inertia. That's basically different from the grid forming, what we have been using nowadays mostly. Okay, that's the first one, I think, is the major one. The second one, we can use other devices like a synchronized generator with primary mover. So there's basically the synchronized condenser. Those can provide the inertia back to the power system grid. Another thing, I think we have more and more power, energy storage system. So basically, we can use smart inverter control. Those can basically mimic the synthetic inertia, which has a faster frequency response into the system. Also can combine with fine wheel or super capacitor. Those stuff can, with battery, can further boost those kind of capability. Of course, as the Jennifer mentioned, the picking plants, like gas-fired picking plants, can always taking the role as the stabilizer of the the power system. So I think technically that's why I can think of maybe four ways to improve the inertia of the system. Yeah.
Could I ask a follow on that, Dr. Wu?
Sure.
Portugal and Spain, and Hawaii, at what point of solar saturation, battery storage saturation, do you have to be concerned about that level of
Mhm.
volatility?
Yeah, I think as the mentioned before, every kind of country or some pushing the 100% of the renewable energy, but definitely this is the ambitious goal. But all agree that pushing to a certain threshold, the reliability or stability is going to be a huge issue for the system. So I'm not quite familiar with the European system much, but I still believe that up to a certain kind of percentage or something like that, that situation will occur over there. So yeah, I don't have maybe the first hand numbers over there. Yeah.
Yeah, I look at, it seems like sometimes, the issue of Portugal or, what we're seeing in Hawaii is brought up as a barrier to why we can't move more renewable energy forward. And that's kind of in the policy talk in a lot of ways.
Mhm.
But when you look at, the small amount of solar Kansas has, it feels like we're a long way from that kind of scenario here. And so I don't want us to get, absolutely the technical solutions have to be explored and we have to know what we're going to do, but we shouldn't let that stop us from moving forward. I guess is the point that I would try to make. I also think that Kansas is fortunate to be part of the Southwest Power Pool, who's working to balance all of that power. And if we have a sudden drop off of renewable energy in our state, the likelihood that another state is going to have the capacity to be moving that power to the places it needs to be. We've seen that happen across the grid, and the Southwest Power Pool is now moving into the West. They're moving into the Western Connection. So not just the 14 states throughout the Midwest, but opportunities to balance power across interregional grids as well, I think really helps us as we get more and more clean energy. And Donna, I might just remind you that William Dorset had his hand up for quite a
I'm
while.
so sorry. Bill, why don't you just speak to us, Bill. I've been monitoring all of the information pouring in through the chat, but go ahead and state your comments.
I'm sorry. My brain has moved on from the question. I don't remember what the question was at this point. Thank you.
Yeah. Uh, with regard to some of the first presentations that were made, the technical ones, I have a question myself about how close and we are to actual investment, perhaps in the agri-industry itself, for the technical suggestions that were piloted already. How close are we, and will it be private big agricultural business that will take up the cause of generating energy through the Green Algae Project? Or is it something that requires much more of a public push? Is there an investment opportunity for agribusiness to take that step in the commercialization?
The question might be water again.
Water?
Yep, water supply may be the big issue.
Yeah, I think that Bill said is right. I think in our work on this food, energy, water, so the water is the biggest concern. So even we use the water as the hydrogen, provider, but in the Kansas, a lot of saying against that, maybe that option because the water is a scarce resources in basically that we don't have much in Kansas. So yeah,
Or in
I agree with
Kansas
that.
anyway.
Yeah.
If I may, just real quickly, a lot of our synthetic fertilizers in Kansas and across the country, across the world, are made by using gas. So if we could have a lower cost input to making synthetic fertilizers that might green the whole supply, like a green hydrogen or a white hydrogen, that could potentially lower the input cost for farmers, and then that looks a lot better in terms of buying fertilizers, etc. So just always making things lower cost can switch the actual consumer trend and therefore the supply.
I think that said is right. I think our motivation here is that because the price for the fertilizer fluctuate a lot, internationally. So can we just produce our local fertilizer in terms of buying, high price from the outside? So that's, one of the motivation we're looking into. Yeah.
Any other questions or takeaways that people are saying we need to be focused on as we go away from this informative seminar? Where do you feel motivated to move personally or within the work set that you're in?
I'd like to invite Blaise Levin to make the comments that he wanted to make, and we're about out of time. And Blaise, if you have some comments, please go ahead.
Sure, thanks, Larry. And that's sort of the question I'd be talking to anyway, Donna, that you just posed. And so at the Center for Hazardous Substance Research, kind of one of the co-hosts of this today, our big focus right now is providing technical assistance to communities that are kind of redeveloping old, kind of developed area of their towns and things. And so it's exciting to hear about a lot of these technologies. And in my mind, sort of the community power solutions could be especially relevant where a community may have a goal to, become more resilient or sustainable with respect to power. And we help them in that case or in any case, whatever they're thinking about, kind of consider the economic, environmental, and sort of community or social feasibility, that sustainability triple bottom line analysis of how that could work, and kind of again listening to the microgrid distributed systems type thing in rural or small sort of local applications. That's really exciting, and thinking about getting those types of technologies implemented on the ground is again what we would be advising communities on. So a few things come to mind with respect to that. We would that have been mentioned already. We'd like to keep safety in mind. While proximity of all of the technology features is important to make it economically viable, proximity to humans. So with respect to, where perhaps hydrogen plants and fertilizer plants are located, and proximity of a lot of the electrical infrastructure, nothing too different than uh, conventional power type things probably, and commercial type things, but still these are all things that need to be considered when these things are designed. And are they still efficient? Are they still going to be economic? Resource availability, like water, certainly some of the technologies discussed earlier require water. So where water is more plentiful, where renewables still are can be generated well, those are kinds of siting things. What states is that going to be more feasible in? You know, how maintaining soil quality for good ag production. That's the comment earlier about salts and fertilizers. That's important to think about with the long-term health of soil. So we just think about all these things. Just a general comment as a non-expert in renewables is, it does seem like there's certainly a lot of untapped potential yet in developing solar, either in commercial scale or utility scale development, and also in rural areas, agrivoltaics. That seems very interesting to me, and could have, is, and could be having a big impact on uh, allowing growers, more sort of family farm scale growers, to be able to do that successfully, and also figure into in a positive way, maybe to the energy, some of the energy needs we're talking about. So those are my comments. Really enjoyed listening to all the speakers, and it's great that we're all trying to figure this out. And I think this is what helps get things figured out, is these forums and the good work going on by Dr. Wu and our other speakers that are doing things in various ways. So those are my comments, and I'll turn it back over to Donna and Larry for any additional discussion.
Thank you, Blaze. I would like to say thank you to everybody. I think we've had a great program, and Blaze, your agrivoltaics might be a good topic for a future dialogue on sustainability. And I invite all of you to put your ideas into the system. Hannah Craig has been helping us, but Blaze and Hannah and myself, those are people you could submit your ideas to. And Nate Blair, thank you very much for coming and helping us. One of the great things about Zoom is the travel costs are and from that standpoint, it's easy to bring in people from further away who are helpful for us. So I will say thank you, and thank you, Donna. You did a great job, and thank you, Jerry Snyder, for being our Zoom host and helping us in that way. And so this 2 hours now gets put into our sustainability seminar video collection, so students can take and watch these things. And so we're hopeful that students will learn from this as well. So thank you.
Larry, thank you very much for keeping this dialogue going. We really appreciate it.
Well, you're welcome.
Donna, just quickly, if you want to hear more, learn more about what's happening around the state, invite you all to join us at Future Forward on October 8th and 9th. Thanks, Kent Rowe, for submitting a proposal to speak. Others that might be here interested in presenting information or ideas, you can find how to submit a proposal on the website I dropped in. Also, for those of you at K-State specifically, we're adding a poster session to this year's Future Forward conference. And so we'll be promoting student research. So for those of you at our universities, please check out the website and feel free to reach out if you have questions about including any of your students or any of your research. Thanks
Thank you.
again, Larry and Donna.
October. Thank you.
Thank you for bringing that up, Dorothy.
Thank you, everybody.
Goodbye.
Thank you. Thank you for organizing this. Thank you.
Thanks for
Bye. Thank you.
Thanks for presenting, Dr. Wu.
Thank you. Thank you. No problem. My pleasure.